Hello, my name is Yeon-Seung Jung, and I oversee the high bandwidth memory DRAM lineup at the product planning team of SK Hynix. I wish to take this time at GTC 2022 to introduce HBM3, our hallmark and latest HBM product. I will start with an overview of the HBM market, discuss HBM3's features and applications, and lastly, introduce SK Hynix HBM3, which was successfully developed in 2021. HBM is specialized DRAM that first launched in 2015 with a focus on high bandwidth needed by AI machine learning or supercomputers. The market is still relatively new, and the main applications have been accelerators or high-performance computing so far. But I expect it to diversify into cloud data centers, driving assistance systems, and further into high-performance main memory for servers and other networking systems. More and increasing demand would come from other devices and systems that require high-speed DRAM as the 5G era unfolds. Overall, the HBM market size is set to grow exponentially at a 40% CAGR between 2020 and 2026, which is 3 times faster than DRAM market growth in the same period. On the right, you can see the trend of change between HBM generations. As of Q1 2022 present, HBM2E is the major product in volume production. SK Hynix new HBM3 will become available late in the first half of this year and begin to gradually gain share then on. As the two most recent generations of HBM become market dominant with increasing supply of HBM3, the earlier HBM2 would be naturally squeezed out. But later on, a second generation HBM3 is expected by mid-2024, followed by an HBM4 with an entirely new platform in the late 2026 or 2027. Now, for emerging HBM markets, HBM continues to diversify away from conventional AI inference and training applications. One market segment that HBM is sure to expand to in the next 2 to 3 years is autonomous driving. Levels 4 and 5 of complete autonomous driving, to be exact. At such level, a car must be capable of making and executing decisions without driver's interference based on changes in the surrounding environment and object perceived. This will require real-time processing of massive data collected through cameras and other numerous sensors. HBM's massive bandwidth will become necessary in this regard, driving full-blown market expansion from 2025 as level 4 to 5 ADAS systems take off. ADAS will require around 600 GB to 1 TB per second for DRAM bandwidth for level 3 systems, and nearly 1 TB to 1.5 TB for level 4 vehicles. Some models install the same hardware in main and sub-units for redundancy, requiring twice as much hardware per car. Importantly, reliability is a feature that differentiates automotive chips from commodity products. Unlike general-purpose servers or desktop computers in mostly stable, predictable environments, cars are exposed to long-time use in harsh environments, from the extreme cold of Arctic regions to scorching heat and humidity, which pose a direct risk to survival of the driver and passengers within. As such, it is imperative that cars ensure high levels of reliability and quality for protection against changes in surrounding temperature and environment. Furthermore, given that a single vehicle is required to keep using the same set of semiconductor chips fixed at production, automotive memory is expected to ensure 5 to 10 years of production support. Let me now explain HBM's position within the memory hierarchy. Memory semiconductors are segmented depending on their purpose according to the von Neumann structure to optimally support the central processor's computation. HBM is multifunctional DRAM that can serve both as a low-level L4 cache that handles large data near the processor, as well as main memory that sits farther away. Further down the hierarchy are commodity DRAM and CXL and SSD for data storage. All features considered, HBM is widely adopted in HPC and cloud systems, as well as high-performance graphic cards for compute support and advanced driver assistance systems. Press Worldwide reported on SK Hynix's first HBM memory on October 20, 2021. Our HBM3 was announced as the world's first and fastest DRAM available to date, with up to 6.4 gigabit per second in pin speed and 819 gigabyte per second of bandwidth in a 24 gigabyte package. We have thus explored the performance and feature characteristics of HBM3. I am so confident that SK Hynix HBM3 will be instrumental in meeting extreme data processing needs of the world's AI, machine learning, and HPC environments. With world-leading technology, SK Hynix will continue to drive performance gains for next-generation HBM. Thank you for your attentive listening.